Beneath every American city lies a world we almost never see, a world older than the cars above it, older than the skyscrapers that tower over it, older even than the electric grid that powers it. It is the underground network of water mains and sewer tunnels, the arteries of the early American metropolis. And for more than a century, they carried rivers of clean water and torrents of storm runoff with a reliability modern systems can only envy. Walk down any quiet old neighborhood in Philadelphia, New York, Chicago, or Detroit, and you might be standing over a pipe that was cast in an iron foundry in the 1880s. It has been in continuous service since the presidency of Grover Cleveland. It has outlasted every mayor, every city planner, every road repaving crew, and it has never once catastrophically failed. Meanwhile, cities built new subdivisions in the 1990s, 2000s, even the 2010s, and those pipes, often PVC or thin-walled ductile iron, are already cracking, leaking, bursting under pressure spikes, or collapsing under shifting soil. A modern pipe system struggles to survive 15 years without a major repair. The old cast iron networks routinely made it to 100. Why? Why did the workers of 1890, armed with nothing more than hand tools, steam-powered winches, and muscle, build water systems that outperform many constructed with today's machinery and materials? To understand that story, you have to go underground, into the dim brick tunnels, the hand-packed joints, the iron mains cured slowly under the sun, and the engineering philosophy that valued one thing above all else: permanence. This is the long-forgotten saga of America's early waterworks, and why their legacy still flows beneath our feet today. Cast iron doesn't sound glamorous today. It's heavy, stubborn, unforgiving, a material more associated with stoves and railroad tracks than the lifeblood of a city. But in the late 19th century, it was the gold standard of water engineering. A cast iron main from 1895 wasn't a mere pipe. It was a fortress, a monument to human ingenuity and endurance. In major cities, walls were often an inch thick, sometimes even thicker, designed to withstand pressures that engineers guessed might one day double as populations grew, neighborhoods expanded, and industry boomed. These pipes weren't just built to carry water. They were built to resist the very chaos of urban life. The story begins in the foundries, where molten iron was poured into sand molds. Workers didn't rush the process. The iron was allowed to cool slowly, naturally, often over several days. No chemical accelerators, no modern shortcuts. The slower the cooling, the more stable the crystalline structure of the iron, a literal reinforcement of resilience. Foundry workers in cities like Newark, Pittsburgh, Birmingham, and Cincinnati became masters of this craft. They could hear the iron, feel its vibration. Entire batches were rejected if the metal didn't ring with the right tone when struck by a hammer. Imperfections weren't just mistakes, they were risks to an entire city decades into the future. When the pipes finally arrived at the construction site, the work had only just begun. Crews spent days, sometimes weeks, preparing joints. They wrapped each end in oakum, a tarred hemp fiber, carefully packing it by hand with wooden tools. Then, molten lead was poured into the collars, sealing each joint into a watertight, pressure-resistant connection. The process required patience, skill, and unflinching attention to detail. One misplaced hammer strike, one uneven lead pour, could compromise the integrity of the entire pipeline. Laying a single mile of pipe could take months. But when these joints finally set, they sealed for generations. Many of them are still holding today. Imagine walking through a quiet neighborhood, digging a few feet beneath the asphalt, and finding a century-old leaded joint still intact, untouched, unmaintained, resisting pressure from decades of water flow, It is a silent testimony to the skill and foresight of workers who expected their work to outlive them, and who understood the consequences if it did not. Modern pipes, by contrast, are built under entirely different pressures: financial, political, and temporal. Rubber gaskets dry out or deform. Ductile iron walls are often half as thick as their 19th century counterparts, and plastic pipes, while quick to install and inexpensive, are vulnerable. They can crack under freezing soil, fail when pressure spikes ripple through the system, or deteriorate from ultraviolet exposure if improperly stored before installation. What took months of careful work a century ago is now expected to be completed in days, with speed prioritized over longevity. Early engineers built for a future they would never see, for people they would never meet. Their work was meant to endure, to provide for generations. Modern systems, by contrast, are often built to budget cycles, subject to the whims of fiscal calendars and political timelines. The difference is stark. One approach respects time, material, and craft. The other treats infrastructure as a temporary convenience. And yet, beneath our feet, the cast iron mains of the 1890s continue to remind us that durability was never accidental. It was intentional. Every pound of metal, every carefully poured joint, every slow-cured pipe was part of a vision, a city that could rely on its water system not for 10 years, not for 50, but for a century. These pipes tell a story of patience, precision, and pride, a story that modern engineers are still studying today, trying to understand why some things, once built properly, truly last forever. While cast iron pipes carried drinking water, America's early storm drains and sewer tunnels were built in a completely different way. Cities carved long, arching tunnels beneath the streets, some wide enough to ride a bicycle through, all lined with hand-laid brick. Workers stood knee-deep in mud and groundwater, placing each brick one by one in perfect overlapping patterns that distributed weight evenly throughout the arch. The result was a structure that didn't crack when the ground shifted. Brick tunnels allowed for tiny adjustments, microscopic movements absorbed by the flexible mortar and interlocking arcs. The engineering term is structural redundancy, but old tunnel workers had a simpler way of putting it: brick forgives. These tunnels weren't lined with rebar because rebar didn't exist yet. They weren't sprayed with concrete because shotcrete was decades away. Instead, crews created self-supporting shapes: arches, ovals, horseshoes, each chosen to guide water flow smoothly and reduce turbulence. Walk into a 120-year-old storm tunnel today, and you might find something astonishing. The bricks are still perfectly aligned. Mortar joints are intact. Water flows as cleanly as it did when Theodore Roosevelt was president. These tunnels were built before radios, before airplanes, before traffic lights, and yet they endure. Compare that to modern concrete storm drains, especially those poured rapidly with thin walls and minimal curing time. They often crack along joints, leak groundwater, or collapse when soil shifts. Many cities replace concrete drain sections every 30 to 50 years. The hand-built brick tunnels? They just keep flowing. Early infrastructure wasn't simply overbuilt, it was overcrafted. And the difference matters more than most people realize. If you look at photos from an 1890s waterworks site, one thing becomes obvious: everything took time. Workers lowered pipes into trenches using block and tackle. Horses pulled sleds loaded with iron. Surveyors placed stakes manually, adjusting pitch inch by inch. Crews tamped soil by hand, layering it to protect the pipe from hard freeze. Every step was deliberate. Slow wasn't a flaw. Slow was a design choice. Early engineers believed that water systems were generational investments, the kind of thing a city might only build once. They didn't have cost-benefit spreadsheets dictating construction timelines. They didn't have political pressure to finish before the next election. They had an ethic. If it's worth burying underground, it's worth building to last. Curing was sacred. Brick tunnels cured for weeks. Mortar was allowed to harden naturally, not chemically accelerated. Concrete, in its earliest forms, was mixed thicker, wetter, and allowed to sit. Even wood, in some rare early pipe systems, was soaked and swollen to create natural seals. Contrast this with modern projects where concrete trucks line up, pouring hundreds of feet of drain channel in a single afternoon, with construction schedules that leave no time for slow curing. Thin-walled pipes are buried the same day they arrive, backfilled, and connected to systems running at full pressure within hours. Old waterworks weren't efficient, they weren't cheap, but they were stable. And stability, it turns out, is the one thing you cannot rush. Once early American cities expanded, something remarkable happened. The water systems built decades earlier didn't just function, they thrived. They endured challenges that would cripple modern infrastructure. Cast iron mains from the 1890s carried pressures that exceeded engineers' wildest predictions, even as neighborhoods swelled around them. Brick-lined storm drains handled torrential rainstorms, absorbing runoff from streets that were paved long after the tunnels were built. They accommodated automobiles, heavy carts, and city growth that no one at the time could have imagined. Pipes that were buried when the population was a mere 80,000 continued working flawlessly when the population soared to 500,000, when industry boomed, and when traffic above ground increased exponentially. The evidence is everywhere if you know where to look. Boston still operates cast iron water mains laid in the 1860s, feeding countless homes and businesses without a major failure. In New York, brick sewers from 1850 quietly carry sewage beneath the boroughs, completely invisible but entirely reliable. Philadelphia's 19th century mains remain some of the most stable sections of its entire grid, resisting pressure, corrosion, and decades of urban development. Cleveland, Baltimore, and St. Louis still rely on pipes older than the tallest buildings in their skylines, silent witnesses to generations of city life, still delivering water day after day. These systems didn't merely survive their design lifespan by a few years. They exceeded expectations by 70, 80, sometimes a full century. Think about that. Pipes and tunnels built before automobiles were common, before electricity was in every home, before skyscrapers dominated the horizon, still working flawlessly today. Compare that to modern infrastructure, which struggles to last even half a century without major rehabilitation. And the contrast is staggering. So why did these old networks perform so well under such expanding loads? The answer lies in the philosophy of overbuilding. Every element was oversized. Pipe diameters were chosen not merely to meet immediate needs, but with absurd margins to anticipate future growth. Water towers weren't just tall, they were massive, providing a stabilizing pressure buffer that absorbed fluctuations in demand. Flow channels were meticulously shaped, designed to reduce turbulence and prevent stress points, all decades before computer models could simulate such flows. The entire system worked as a cohesive unit: slow curves, thick walls, forgiving joints, and gradual slopes. Every choice reinforced durability. Even hydraulic shock, the violent pressure spikes that can make modern plastic or thin-walled iron pipes burst, was no match for these systems. The early networks absorbed shocks naturally. Heavy walls resisted sudden expansion and contraction. Flexible joints allowed microscopic movement. The arches and tunnels beneath the streets distributed stress evenly. Nature and design worked together to ensure that a heavy rain, a sudden demand surge, or even a shifting street above wouldn't send pipes splitting underground. And there's more. The century of service wasn't an accident. It wasn't luck. It was an inevitability embedded in the very bones of the system, a product of deliberate choices, painstaking craftsmanship, and engineers who designed for a future they would never see. They built not for efficiency, not for speed, and not for cost-cutting. They built for generations, for stability, for permanence. Every time a 19th century pipe continues to flow today, it is a reminder of what thoughtful engineering can achieve. It's a living legacy, a silent testimony that when you combine careful design, quality materials, and meticulous construction, infrastructure can outlast entire lifetimes, entire eras, even entire centuries. And perhaps most astonishing of all, these systems did all of this without any of the digital simulations, rapid construction techniques, or advanced plastics that dominate modern projects. They succeeded because their builders understood one fundamental truth. Some things are worth doing once, and doing them right means building for 100 years, not a decade. So, if the old waterworks were so remarkably durable, why don't we build like that today? Why do modern pipes burst, crack, and fail after just a fraction of the century-long service their 19th century predecessors achieved? The answer begins with money, but it doesn't end there. After World War II, America entered an era of unprecedented growth. Suburbs mushroomed almost overnight. Cities needed infrastructure fast. And the priority shifted from durability to speed, from thick walls to thin, from careful craftsmanship to standardization. Everything had to move quickly. The roads, the houses, the water mains. Time became more valuable than permanence. PVC pipes replaced iron, not because they were superior, but because they were cheap, lightweight, and fast to install. Modern ductile iron pipes were manufactured thinner, cutting costs but also cutting resilience. Concrete, once carefully mixed and allowed to cure over weeks, was now poured rapidly with chemical accelerators that promised speed but sacrificed long-term stability. The mentality was clear. If a pipe fails in 20 years, it can simply be replaced. Longevity became a luxury, no longer an expectation. But material choices alone don't explain the failures. The bigger difference, the silent killer of modern systems, is maintenance. Early cities understood that infrastructure failure was not an option. A broken pipe meant fire hydrants didn't work. Flooded streets meant disease outbreaks. Engineers and laborers were constantly digging, cleaning, inspecting, and repairing, long before technology made it easier. Maintenance wasn't a line item in a budget. It was a civic duty, a moral imperative. Today, the story is different. Maintenance budgets are often the first to be slashed, trimmed away to balance city books or appease taxpayers. A small leak ignored today becomes a large leak tomorrow. That large leak can create pressure waves, sending shock through the system. The pressure wave weakens a joint, cracks a wall, and suddenly a burst happens, often in the middle of a busy street in front of unsuspecting commuters. And then, of course, it makes headlines. Water main explodes, the story reads, accompanied by dramatic photos of gushing water and ruined pavement. Compare this with a cast iron pipe laid in 1895, quietly carrying water beneath a street in Chicago or Boston. Nothing makes the news because nothing goes wrong. The pipe flows as intended, day after day, century after century, unnoticed but unfailingly reliable. The absence of spectacle, in this case, is the true measure of success. Engineers recognize this. That's why universities still study these old networks. They examine joints sealed with molten lead, thick iron walls, oversized pipe diameters, and brick-lined tunnels. They look for clues to understand what modern construction sometimes forgets. Durability isn't a mystery. It's a choice. It comes from overbuilding, from patient workmanship, from designing systems that outlast not just budgets and election cycles, but entire generations. Modern engineers often lament that today's infrastructure is failing. But the truth is, it isn't failing because the material is inherently weak. It's failing because we've abandoned the mindset that made the old waterworks so enduring. We've traded patience for speed, resilience for cost, craft for convenience. And yet, there is a lesson buried in those 19th century mains. America once made the choice to build waterworks that could last a century. Those systems didn't just survive, they thrived. They remind us that durability is not a fluke or a miracle. It is a deliberate design, a philosophy, a way of thinking that sees beyond the next fiscal year, the next election, or the next quarterly report. Somewhere beneath the streets of Philadelphia, Boston, or New York, those choices are still flowing, silently teaching us that the failures of modern infrastructure are not inevitable. They are avoidable. And the blueprint for a long-lasting, resilient system is already written, if only we choose to follow it. Stand on a sidewalk in an old neighborhood, maybe a cobblestone street lined with early 20th century row houses, and think about what lies 10 feet beneath your shoes. Down there is a piece of engineering older than your grandparents. It's still working. It's still carrying water to kitchens and bathrooms. It's still guiding stormwater to rivers. It's still doing the job it was built to do, day after day, decade after decade. That's the legacy of America's early water systems. They prove infrastructure can be built to outlive the people who made it. They show what happens when craftsmen are given time, when materials are chosen for strength instead of cost, when engineers imagine a world not just 5 years ahead, but 5 generations. Modern systems fail because we've accepted the idea that failure is normal. Early systems succeeded because their builders refused to accept anything less than permanence. Maybe the lesson isn't that old pipes were better because they were old. Maybe the lesson is that durability is created, not discovered. It comes from thicker materials, slower processes, meticulous construction, and an attitude that some things are worth doing once, but doing right. As cities across America debate how to rebuild their aging infrastructure, many engineers are looking backward for inspiration. They're studying century-old mains, brick tunnels, and hand-built joints to rediscover what was lost when construction became a race against time. Because somewhere down in those dark tunnels and iron-lined trenches is a simple truth. The people who built America's first water networks weren't just building a system, they were building a future. And somehow, unbelievably, it's still flowing today.